everyone. So today I will talk you about a setup that we made inside XGeeks for a client, and the challenge that we have that it was using NAT inside AWS Direct Connect. So this will be the agenda for today. So I will present you the general setup. Then I will try to explain what the problem was, why we use NAT to resolve it. This is to finalize the setup, so it will make sense at the end. So then yes forward at the end of the presentation, of course, that will be a Q&A session for your questions. So first of all, like Rita already introduced me, my name is Luís Serra. I'm a DevOps engineer at XGeeks since 2020, I guess. On that QR code, you have all our social media mediums and so on. So please be free to scan it and to reach out to XGeeks and see what we do on our company. Okay, so to start my presentation, I want to make a small disclaimer. So AWS Direct Connect components won't be covered deeply. What I mean with this, so there are several components inside this AWS product, and you have to choose which one of them makes sense for your purpose or for your scenario, for your environment. So I will try to explain which of them we use, but we won't cover it very deeply and why we implement like that, okay? So to give you some context regarding this, let's talk about the general setup. So this is what we want to achieve, okay? So we are a separated or independent, let's call it independent project inside this client. We have all our things, applications and so on deployed on AWS Cloud, and we want to consume some data that are only available inside our client network. And with that, this is a challenge because we need a secure way to connect our AWS account with the client's network. And with this, we can achieve this using the AWS Direct account. What do you need to set up this kind of connection? So this private and this secure connection. For example, to start, and this isn't updating, okay, so now it's fine. You will need some connections. So this was the first resource that we didn't manage, and it was provided by our client. Why? Because this can be a physical connection, can be dedicated, can be hosted on somewhere. We don't have any power on it. So this was fully provided for our client. But I can give you some characteristics of this kind of resources and you can understand what this is. So usually these connections as a location, so bandwidth configuration, the VLAN that is connected to, so the AWS logical device that is connected to as well. So this kind of characteristics that has made part of a connection, okay? So the next part is to set up a virtual interface. Virtual interface, it was the first thing, the first resource that we deployed inside our own AWS account, okay? Yeah, you can call it like that. It was the first resource that we deployed using Terraform. Once again, you can have multiple, so you can have different types of it. You can have a private or a public, some characteristics, connection ID, of course, because it has a connection associated with it, region, VLAN, type, if it is private or public, sorry, BGP, ISN. So BGP, for those who don't know, is a routing protocol, is border gateway protocol. It's very common between your internal providers, and because this is a connection through the internet, this is why they are using BGP to announce the route and the BGP authentication key and many more, okay? Then, and here it's that part that you have different resources for the kind of implementation that you want. For our own case, a virtual private gateway makes sense. So it was the best approach, or not the best, not the right, but it was the approach that we took, okay? The virtual private gateway, it is a resource that is attached to the VPC, okay? So one of the characteristics of that resource is a VPC ID. and then you can connect it directly into one and only one virtual interface, okay? Virtual interface, exactly. But we have two of them, so we had to choose, and we have to lose high availability, so this doesn't make any sense. So a third resource comes out, and it's called a Direct Connect gateway. So the names are pretty similar. It's a mess to find all this kind of information in the documentation. So this new resource is called a Direct Connect gateway. So it's basically just to achieve this kind of implementation. So it has all the virtual private gateways on the left side, or transit gateways, or wherever, and the virtual interface that is connecting to. Okay. So, and with this, we manage how to connect our own cloud infrastructure with our client infrastructure. Okay. So let's try to identify the problem of this implementation. It's not a problem, it was a problem for our own case, okay? So this should be look something like that, okay? That we have our own VPC with our network address, our public or private subnets. Each of them has its own addresses and so on, and the route table. So this is, let's call it by default, it should look like that. With an internet gateway to reach the outside, and with a virtual private gateway to connect to your client network, okay? And if you analyze that route table, that's the default route table, so it should look like that. A default route saying, okay, everything that I don't know goes to the internet gateway. Everything that is belong or you are trying to reach from my own network, so it's a local, and if everything that you want to reach on that network, so 33.0.0/8, should be forwarded into the virtual private gateway. And this makes sense, okay? This makes a lot of sense since you are using BGP, and you enabled, of course, the route propagation. This is a configuration that you can put in your route table. And let's try this with an example. So if you have a package, so the characteristic of that package, many more are missing, I know, but it should look like this. So the source IP is one of my own resources, and the destination IP should be, let's call this server right here. In terms of routing, this should be working. But what happens if your client only allows you to, or only allows network and packages that came from its own network? You have to somehow to change between this flow, you have to somehow change that source IP, okay? Because if you don't, simply this package will be dropped and it will be deleted, okay? And that's why we use NAT for it. So NAT, Network Address Translation. Now, let's go back a little bit. So first of all, I have to be able to set up a NAT gateway within this network address, okay? Because I have to be able to set up something on this network. First of all, we had to ask our client, okay, or our client, sorry. So, okay, from your network, just give me a small part of it, because I have to have my own address, okay? This is the first thing to do. And with that, you will now have two CIDR blocks associated to your VPC. And now that I am able to set up resources on my client's network, I can have my private subnet, and I can associate to it or configure it to it to use this network address, okay? By the way, so AWS has a limitation, so /28 is the minimum subnet that AWS allows you to use on a private subnet. I know this because client at the first instance they give us a 28 subnet, and I tried to separate this into different subnets, and AWS said, okay, no, you can't do you can't do even lower than that, okay? And now that we have a small part of our client network, we are able to set up a NAT gateway on it. And using the DHCP, so that NAT gateway should receive an IP address within this network address, okay? Let's assume that this is the IP address that we will receive on that NAT gateway. But we still have the same problem. So any request that comes from our private network, private subnets, it will have the same target on our route table. So we have to enforce those kind of package to go through our NAT gateway. And we just have to do this. So on the route table that is associated to that private subnet, we now say, okay, everything that goes to 33.000/8, it doesn't go through the virtual private gateway, but it goes, the target is now our NAT gateway. Okay? And that seems cool. So, okay, I'm now forwarding all the requests for this network to NAT gateway. But that gateway doesn't have any routing configuration, so doesn't know how to exit. Okay, no problem. Let's create a second route table, okay, and associate. Sorry, you can see this yellow line here, but you create a separated route table that is only associated to that private subnet, okay, and should look like that. It's exactly the same route table that we had before on that route table A, but now these kind of configurations are here on the route table B that is associated only to this private subnet, okay? So now if we go back to the same example, this is the package at the beginning. So source IP comes from one of my resources. The destination IP is one of my client's servers. Because of that rule, that package will be forwarded into my NAT gateway, and now the network address translation will work. And my source IP, it will be my own NAT gateway source IP. Okay, and now, okay, you can forward this package to the client, and because the source IP of it is from its network address, you will accept it. So this is fine, but usually users don't work with the IP addresses. They work with domains. So, and we have this kind of problem. So we thought, okay, everything seems fine, everything is working. So let's move on. But then, on the first trying to access one of our client resources, we had a problem that the domain, it wasn't resolved. Okay. And why? Because by default, when you have, so the NAS working way, you will ask for a domain to be resolved on your configured name server, sorry. And if that server doesn't know how to solve that domain, it will forward to the next one and to the next one until reach the top levels, okay? But this isn't the thing that we want, because only this server right here knows how to translate, how to resolve this kind of domain. So it's an eternal domain. So I have to forward my DNS requests not to the internet, or to the default name server, but to this specific name server. One thing that we can do, okay, we can go to our VPC connection, our VPC configurations, and forward all the traffic through this server. And this should work, because if this server doesn't know how to deal with my DNS, the domain that I'm asking for, probably it will follow the default way to work, okay? But is it valuable to forward all my DNS requests into this server? Because it only knows how to resolve my internal domains or my client internal domains. And with that, so AWS, so specifically the Route 53 service, that is the DNS service of AWS, they have a thing called resolver. And on that resolver, we can create an outbound endpoint with one rule saying, okay, on my VPC, everything that you are trying, or all the domains that you are trying to resolve for my company.internal.domain, please forward that kind of request to this name server. And because all the network configuration are already set up, it will follow the example or the flow that I showed you before. So only for this specific domain and two domains, it will be forwarded to this DNS server. And that's it. So this was how we managed with this problem. Why we have this problem at the first instance. And now, guys, it's time to get some answers. Thank you for your time. Sure.
I have one question regarding can you return to the DNS resolution slide?
Yeah.
Let's say that I'm on this product and I'm not actually using AWS properly. Let's say I'm using OpenStack or some other source. What if I wanted to perform this DNS resolving without actually relying on Route 53? Can I somewhat implement some sort of caching to do DNS resolving on this end, or at least save the most frequent resolution so I can on cache so I can use it regularly?
The first question is your OpenStack running inside our AWS account?
No, I'm not putting it like I don't want to rely on managed services. Let me put it straight. It's not quite. I just say OpenStack, but just as an example. Let's say not specifically doing it on AWS, but on a different provider. Could I use caching like for this scenario, or would it be like a problem?
For this specific scenario, I don't think so. So on my previous project, I did something like that you are talking about. What I did was, so I put a DNS server on front of it. I think it was a bind 9. And I intercept those kind of requests, okay? So everything that I don't know, go with the flow, let's call it, and go with normal DNS propagation, okay? And all the internal domains, I was forwarding them into my private DNS server, okay? And for example, on that case, it will be possible, and it was feasible to enable cache DNS, okay? But on this specific case, I don't think that will work, unless that I don't know if Route 53 has some kind of cache, and that's an answer that I don't know. Okay.
Okay, that's cool.
Sure.
Why was your customer so resistant to opening up? Because, like, if I were a customer, I would not want this NAT thing to happen, because then when I'm seeing traffic, I break the assumption that 43 is in my network, in my domain. Whereas, it could be coming from an AWS network that I don't have control over.
Yeah, but they are very closed, and they only. So I don't know if I understand your question. So first of all, this client has a lot of restrictions in terms of security. Okay. This was the only way that they give us to connect our AWS setup into their own infrastructure. Okay. So this was something that we can choose. Okay. Sorry, what was the second part of your question?
So first of all, I was just thinking, like, is that more secure? Because now I have.
Because
I'm basically masquerading traffic in my domain that's external to my domain. So now I have traffic, I have TCP packets in my network that originated from outside of my network, but it looks like it's in the network. So that seems less secure.
Okay, yeah, I understand that. So the first thing is they force us to follow this implementation. Okay, so this was something that we didn't have any influence on that. And regarding the requests that are being made through their own, or they assume that they are done using their own internal domains. I understand because we have a NAT gateway, but actually they know that those kind of requests or those requests are made from us because they were the ones who gave us this small portion of their network. Okay, so yeah, they don't know which kind of application or whatever is doing the request, but they know. I think at least it should they should keep this track. But they know that okay, everything that came from this small network, it's coming from this specific project because we gave them this network address.
I think you answered, but just to
Mm-hmm.
be clear.
Oh.
So they don't have any way of tracing from which of your private subnets or devices or servers on your network which generated the request.
No. So if you want, yeah, for their side it's only a package that it comes from.
Device that's emitting all the packets that come from.
Yeah. If you want to track, but it's a nice question because if you want to track which application is my application, it is right here. It's making requests to this server, specific server. I think you have to use some tracing tools. So something that it will inject a span ID and a trace ID into the package and will follow all the way.
Because then like they lose the
Exactly.
ability to
Exactly.
get any rules based on where it's coming from.
Yeah.
Okay. Thanks.
Questions for Luís? So, thank you so much, Luís. I think
Thank you. Thank you so much.